Hi, and welcome to Better Code Today. My name's Tim, and today I'm going to be talking about immutable types. I'll cover what they are and how they can help you write better code before taking you through a simple example showing how you can implement an immutable type in your own code. Wikipedia describes immutable objects as an object whose state cannot be modified after it's created. This means that for an immutable object, you must set its data on construction, and then it will never change for the lifetime of the object. This makes immutability great for a number of uses, including but not limited to data transfer objects. You can have great confidence that when you're reading data from the object, you're getting the exact data that was put into it on the constructor. There's no need to track the object through its life cycle to find out what else might be using it and potentially modifying it. So long as the object is created with the correct data, it will still be correct when it's read. Another advantage is that it becomes easy to test if two immutable objects are equivalent. If the two objects have the same data, then they are and always will be equal. This may mean that you need fewer objects, as there's no need to store more than one object with the same data, potentially saving memory. Immutable objects are also inherently thread safe. If you can't change them, then you'll never get issues where one thread changes the object while another is using it. It simply can't happen. The object state is fixed and will never change. The only real disadvantage to immutable types is the same thing that makes them so great. You can't change their data once they've been created. This may seem like a serious problem if you're not used to the concept. It certainly means that immutability isn't suitable for all types. Larger, more complex classes probably won't be immutable, but once you get used to creating and using immutable types, you'll probably find all sorts of places where they could be useful. If this all sounds like a strange new concept, it really isn't. The .NET framework already includes a number of immutable types, the most famous being system string. Once you create a string, you can't modify it. All you can do is create new strings by manipulating the original. Methods like replace always return a new string, rather than affecting the string they're called on. Internally, the .NET framework also takes advantage of the equivalence I mentioned earlier, so that it only has to store equal strings once, reducing memory usage for the application. Other .NET immutable types include all the basic number types, such as int, double or decimal, as well as system and date time. Microsoft actually recommend that all value types are immutable, although as usual they don't always follow their own advice, so there are also mutable value types in the .NET framework. In a moment I'll show you how to create an immutable type, but first I want to get something off my chest about the ReadOnly keyword. ReadOnly is very useful in creating immutable objects, but there is a problem with it. It lies to you. It doesn't really make things read-only at all. What it actually does is make it so that the reference to the object the field refers to can only be set on construction of the object, and any attempt to modify it later will cause a compiler error. This is a subtle difference, and I can understand why Microsoft went for the shorter keyword, but if you're going to write immutable objects, you'll need to understand it. If the field is immutable, like the double value in the example shown, then we're safe. The value field will always point to the value provided in the constructor, and that value can't be changed, so we don't have a problem. However, if the field type is mutable, like the list values, then while the field will always point to the same list, there's no guarantee that the list itself won't change. Someone could clear all the items from the list and replace them with a bunch of new values, and the compiler would be quite happy with that. It may be that you're happy with that too. It's up to you as the developer whether your immutable type should only consist of immutable fields or not. If so, the framework provides a few read-only objects or collections you can use. Or a useful trick is to create a copy of the immutable object in the constructor and just don't expose the object copy externally, effectively placing the immutable object in an immutable jail that prevents it from being modified. So now let's have a look at how we can make a simple object immutable. I thought the easiest way to demonstrate creating immutable types would be to show you how to turn a simple mutable class into an immutable one. If you look here at my beans class, you'll see it's a class for representing a mass or weight of coffee beans. The beans can be roasted or ground by calling the appropriate method, and there's an override of toString that gives us a description of the state of the beans at that time. I've created a simple console application to demonstrate the use of the beans class. It creates an instance of beans, roasts them, grinds them, and at each point prints the state to the console, like so. You'll see that the state changes as we progress through the sequence. The class is already quite well encapsulated. To affect the state, you have to call the appropriate method, but the class isn't immutable. Calling the grind or roast methods will change the state of the object, and for any of the reasons we discussed earlier, that might not be what you want to happen. The first thing we'll want to do to make this class immutable is to make the fields read-only. As I mentioned earlier, if the field types aren't immutable themselves, then this won't be enough. If we were using collections, then we'd have to swap them out for read-only collections, or be very careful that we don't use or expose any of the mechanisms for changing them. Here that isn't an issue though, as double and bool are both immutable types. As soon as we make this change, we start getting errors. As the fields are read-only now, we can't set them in the roast or grind methods. Instead, what we're going to have to do is modify these methods to return a new instance of the class where the change we want has already been made. So we modify the roast method to return a beans object, and in the method itself we're going to return a new instance of the beans class with the mass and the ground status taken from the current object, but the roast status forced to true. Like so. We should probably have some validation in here to check that we don't roast the beans twice or grind them after roasting, but that's not relevant what I'm trying to show here. We also need to make the same change on the grind method. Again, change the return type from void to beans, and in the method itself return a new instance of beans using the same mass, setting ground to true and using the same roast status, like so. And now the red squiggles have gone away and we can build and run the application again. You'll quickly see a problem though. The beans aren't updating their status anymore. Well, actually that's exactly what we wanted. The beans object is now immutable and it won't change state, so we need to work with it slightly differently than we did before. What we need to do is every time we call a method that makes a state change, we need to set the beans variable to the result of the method, like so. Beans equals beans.roast and beans equals beans.grind. It's as simple as that, and if we run the code again, we will see now that everything's updating as we should. We get the roast beans and we get the ground beans. Of course, we don't have to assign the result of the methods to the same variable we started with. We could quite easily create a new variable for the roasted beans and a new variable for the ground beans, and then keep hold of the original object. This is something we couldn't do with the mutable version of the class. So that's all I've got for you this time. Hopefully you now understand the role of immutable types and their advantages. You also saw in the demo how you can change a simple mutable type into an immutable type, and the changes you need to make to the calling code to support it. There's a lot more you can do with immutable types. I often find it useful to write overloaded arithmetic operations on immutable types, so you could, for example, add two masses of beans together, but that's probably a subject for another time. I really hope you enjoyed the video. If you did, please take the time to subscribe to our YouTube channel or follow us on Twitter. As always, if you have any questions, comments or ideas for future videos, just let us know. Thanks for watching.